All right, so in order to derive the vertex formula, we're going to need a couple of definitions. Let's start off, I'm going to write the vertex formula. We're going to say vertex is equal to negative b over 2a, comma, f of negative b over 2a. And that is our, get the closing parenthesis, that's our vertex formula there. So the first definition we're going to write is just a quadratic function. So we're going to say quadratic function is equal to f of x equals ax squared plus bx plus c, where a, b, c are constants and a cannot equal 0. Alright, because that would make this a linear function, right? And we know that x is the variable and it's the independent variable as denoted by function notation there. So the other definition we're going to need is of a quadratic function in standard form. Or it might make more sense in this case, easier to remember, in vertex form, right? So that's going to be f of x is equal to a times x minus h squared plus k, where a cannot equal 0 again, and h comma k is the vertex. And again, we know x is the independent variable because it's denoted from function notation there. So to start off our proof to get the vertex formula, we're going to have to take this and we're going to have to put it into vertex standard form or vertex form by completing the square. So we're going to take f of x equals ax squared plus bx plus c, and we're going to start to complete the square, but now the coefficient of the a term has to be 1, so here it's a. So in order to do this, we have to factor out an a. So we'll say f of x is equal to a x squared plus b over a, because remember we took out an a, so everything is divided by a, x, and we're going to leave the c term alone. We'll say plus c. So now, in order to finish completing this square, we have to take the b term and divide it by 2 and then square it. So say plus b over a times x plus b squared minus 4a squared, because that's b over a divided by 2 squared. But in order for this to work, we have to use our additive identity, which is 0, and we don't want to change anything here, so we're going to also, so using our additive identity, we're going to subtract b squared minus 4a squared as well. So this isn't changing anything. This isn't changing the function here at all. It's still the same because we're adding and subtracting the same value, so it's essentially 0. So now what we're going to do, in order to continue completing the square, we're going to take the subtract, we're going to take this one, negative b squared over 4a squared, we're going to take it out of the parentheses here. So we're going to say plus b over a x plus b squared over 4a squared, and it's going to be plus c minus b squared minus 4a squared. But you got to remember that because in here it was really multiplied by a, we just divided everything by a, and the a sits out here. But because it's no longer in the parentheses, we have to distribute the a back into this value. So it would end up being b squared over 4a. So that square is out of the game because it distributes in. Then you have an a up here, and it divides into 1a down here. So then from here, we have f of x equals equals a. If we continue completing the squares, it's going to be x plus b over 2a squared plus c minus b squared over 4a. So from here, we can tell that this is pretty much in our vertex form, but we see how we have a minus here and a plus here. So we know that this is actually going to be minus negative b over 2a squared plus c minus b squared over 4a equals f of x. So now that we have this in terms of vertex form or standard form, we know that h comma k is the vertex if we reference our definition here. So let's look at down here. What do we have for h, which is the x value of our vertex? Well, we have negative b over 2a. So we'll say our vertex is negative b over 2a. And what do we have for our k value? We have c minus b squared over 4a. Now, you might see that this is this up here, but down here we have this. Well, that's because if you have your x value and you plug it into your quadratic function, you're going to get out the output, obviously. So that's why we get the vertex formula is, we can take this and say it's negative b over 2a comma f of negative b over 2a. Because if you plug in negative b over 2a into your quadratic formula again, you're going to get this output every time, because this is the output. It's the y value, or the output. So, or your k. So that is going to be the vertex formula. And that's why that is. That's the proof.